Hello everyone, I am DHANVANTH from Mechanical Department VIT and today we will be solving a problem from force couple system 2D. What is force couple system? Force couple system in 2D simplifies the analysis of forces acting on a rigid body by reducing them to a single resultant force and a couple. This method is crucial in statics and dynamics, allowing for easier calculations of mechanical responses. The resultant force representing the total effect of individual forces and the couple capturing rotational effects enables engineers to efficiently design and analyze structures and components under various load conditions. And today we'll be solving a problem from force couple systems, and without any further delay, let's get in. And this is the problem we'll be solving now, and it says replace the loading system acting on the post by an equal resultant force and a couple moment at point A and at point B. All we have to do is simple, we have to just replace the loading system by an equivalent resultant force and a couple moment. And here is our free body diagram. Here we take 650 Newton force as F1, 300 Newton force as F2, 500 Newton force as F3, and the components of F1 and F3 are given here. We know that F2 has no horizontal components. And we are required to replace the loading system by an equivalent force and a coupled moment. F2 is equal to minus 300 newtons. We know that it is in the opposite direction, and the horizontal component of F1 can be calculated by resolving the components of F1, and we get it as 325 newtons. And in a similar manner, we can get the horizontal component and vertical component for F3 by just resolving the components of F3. And here we get the horizontal component of F3 as minus 250 Newton and the vertical component as minus 433 Newtons. And now here we take I as horizontal component and J as vertical component, and all we have to do is just simple. We have to just add the forces and find the magnitude of it to get the single resultant force, and here we get it as 1298 Newton or 1.30 kilonewton approx. And the equation of the angle made by the resultant force with x-axis is given by theta is equal to tan inverse of summation of f of I by summation of f of x. And if I substitute the values in the above equation, I will get the theta as 86.7 degrees. And there is also a method too. We can also solve by using equilibrium conditions, and summation of f of x is equal to 75 newtons and summation of f of y is equal to minus 1295.9 newtons, the same as before. And if I substitute this in the formulas given below, I will get the same answer as before. And moment. What is moment? A simple way to define moment is force into perpendicular distance, and if the direction of the moment is anti-clockwise, it's positive, and if it is clockwise, it's negative. And here we have to find the resultant moment of at point A, and here we get it as F1y into 3 meter plus moment minus F3y into 5 meter. If I substitute the values in the above equation, I will get the moment at point A as 1023.73 Newton meter, and it is in anti-clockwise direction. And in a similar way, we can find the moment at point B, and it is given by f of 1y into 10 meter, f2y into 7 meter, f3y into 2 meter plus m. And if I substitute all the values in the above equation, I will get the final answer as 10095.1 Newton meter, and it is also in the anti-clockwise direction. And the final answers are resultant force, which is equal to 1.30 kilonewtons, and the theta, which is equal to 86.7 degrees, and the resultant moment at point A, which is equal to 1.02 kilonewton meter and anti-clockwise direction, and resultant moment at point B, which is equal to 10.1 kilonewton meter, and it is also in the anti-clockwise direction. Thank you.